Good day guys, today we are doing standard form. So what we have to know is that standard form is a form of representing big numbers. Big numbers, they will be raised to what? To a particular index there. Then the other key concept with the standard form is that if a number is expressed in standard form as we write it, I denoted that number by what? By an x. Our x is always in between 1 and 9.9. Standard form is ranges from 1 to 9.99. It's infinity there, but you'll never find as a number in standard form that is 10 and above. So I have two distinct type of numbers that I'll use so that you maybe understand. I categorized my numbers into two. I've got what I call normal numbers. I've got what I call abnormal numbers. This is a method of making you to do what? To understand this concept very quick. So I said a normal number is a number that is greater than 0. So 1, I can regard 1 as what? As a normal number. Then abnormal numbers, these are numbers that are less than or equal to 0. So all decimals that begin with 0 are classified as what? As abnormal numbers. So we're going to use that approach so that you try to understand this concept. So here is my example. I want to represent 2723 in standard form. In this case, the concept says, is it a normal number or it's an abnormal number? In this case, this is a normal number. Whenever, if we have normal numbers are supposed to have what? A positive index. Then abnormal numbers are supposed to have what? A negative index. So in this case, it's equal to, so as I said, in standard form, numbers range from 1 to 9.9. So in this case, this is our standard what? Position of the comma. Always, if you're given a number that doesn't have any comma, the comma is assumed to be what? To be on the last digit. So your comma is going to move 1, 2, 3 times. So that's 2.723 times 10 to the power. How many times did you move your comma? 3. So that is your answer. You have expressed your number in standard form. Here may be 0.02371. It's equal to. So is this a normal number or it's an abnormal number? This is an abnormal number. So if it's an abnormal number, our index is supposed to what? To be negative. So how many times is a comma supposed to move? It's 1, 2. So it's equal to 2.371 times 10 to the power. Our comma moved how many times? 2. So that's a negative 2. This is the very basic concept that you're supposed to understand. That's the very basic concept that you're supposed to understand. Sometimes you may find a question that comes in the form of a fraction requiring you to convert it into what? Into standard form. For instance, you may find a question saying convert 1/4 into standard form. So you have to first convert this fraction into what? Into a decimal. So you're going to say it's equals to 0.25. Then it's equal to, now is it a normal number or it's an abnormal? In this case, it's an abnormal. So I'm going to do what? I'm going to move my decimal point 1 time. So it's equal to 2.5 times 10 to the power negative 1. It's 2.5 times 10 to the power negative 1. Then those are the basics of what? Of standard form. Now let me take you to what? To addition and subtraction of standard form. If you're doing addition and subtraction of standard form, you will never add or subtract unless if you convert everything into what? Into ordinary form. So you're supposed to first convert everything into ordinary form. Let me give you an example. So there is our example. If we are to add there, we're supposed to first convert this what? This number into ordinary form. So this 4 indicates that how many times is your comma supposed to move. In this case, if our index is what? Is positive, it automatically tells us that this was an ordinary number. But then if our index is negative, it tells us that this was a what? Abnormal number. So just bear in mind these two concepts. It will make it easy for you to understand these standard forms. So in this case, if I move my comma 4 times, I'm going to add on 2 zeros. So I'm going to have it's equals to 2, 3, 3, then 2 zeros, plus this side I'm going to move my comma once and then add how many zeros? 2 extra zeros. So it's now 6, 2, 0, 0. I'll then add these numbers. After I have found my answer from this one, I'm going to do what? To leave my answer again in what? In standard form. So let's calculate this one. This is 23,300 plus 60 plus 6,200. Let's add there. So I have found my answer to be what? To be 29,500. I found my answer to be 29,500. So if I'm to convert this number into standard form, I will do away with what? With these zeros that appears last. So I'm going to have it's equals to, it's a normal number. Then let me move my decimal point there. We assume it's here, so it's going to move 1, 2, 3, 4 times. So my final answer is going to be equals to 2.95 times our decimal moved how many times? That's 1, 2, 3, 4. So that's times 10 to the power 4. That is our final answer. That is our final answer. So it say it's the same even with what? With subtraction. Let me give you an example for subtraction. So there is our example. We're supposed to first convert this into what? Into ordinary form. This was a normal number, so it's going to be equals to 3, 2, actually it's the 3, 3, 3, so that's 3, 3, 2, 0, minus, then that one is 2 times what? 2.1 times 100. This is 10 to the power 2, which is my 100. So I'm having 2, 1, 0. That's what? That's my 210 there. That's my 210. Then I'll subtract here. I'm going to obtain. So I'm going to obtain 3,110. Then I'll convert that 3,110 to what? Into standard form. So it's equal to, since it's a normal number, my comma is going to move 1, 2, 3 times. So it's going to be 3.11 times 10 to the power 3. That is my what? That is my final answer there. That is general addition and subtraction. If you're doing addition and subtraction, you are supposed to first convert everything into ordinary form. Let's move on to multiplication and division. Okay, here that's when we start to apply our laws of indices. We want to multiply here. We are going to say it's equal to, we don't need to convert anything into ordinary form. We're going to say 3.1 times 2.25. Then it times, I'm going to take a single 10 here. So it's now 10 to the power negative 4. Then I will apply my what? My laws of indices according to the laws of indices. If I'm multiplying, I add my power, so I'm going to say plus 7. I'll multiply that one is 3.1 times 2.25. So that's equal to, it's equal to 6.975, then times 10 to the power 3. That is my final answer. I'll be done there. Let me give you an example for division. So here, if I'm doing division, it's going to be the same again. So it's equals to 2.25 divided by 5. Then I'll say times 10. Then I'll apply what? My laws of indices. According to the laws of indices, if I'm dividing, I do what? I subtract my power. So it's going to be 4 minus 2 there. I'll then divide that one. After dividing that number, I obtained 0.45 times 10 to the power 2. Now, I'm supposed to be in my standard form, numbers range from 1 to 9.9. So that one is supposed to be in standard form. So I'm going to say it's equals to, my comma is supposed to be in between 4 and 5. So since this is an abnormal number, I'm supposed to do what? To subtract how many times that comma will move. It's going to move one time. So it's going to be 4.5 times 10 to the power 2 times 10 to the power negative 1. It's equals to 4.5 times 10 to the power 2 minus 1 equals 4.5 times 10 to the power 1 is just to the power 1 there, so it's not necessary for you to do what? To write the 1. Then let's move on to standard form that applies what? The concept of square roots. Okay, there is our question. It requires us to solve there. So you're going to come here and say, first determine the square root of what? Of 2.25. That's 1.5 times 10. Then what you are supposed to know is that whenever, if you find standard form inside a square root, you are supposed to know that this power will always be even. It's always even. So what you have to do is to do what? Is to divide it by 2. So if we divide it by 2, we are going to obtain 4. Then over square root of 4, that's what? That's 2 times. If we divide a negative 6 by 2, we are going to obtain what? Negative 3. So there is my working. I'm continuing there. I now split and say 1.5 divided by 2, then times 10. The first 10 is that one, so it's a to the power 4. I'll then apply the laws of indices. If I'm dividing, what do I do to my powers? I'll subtract, so it's a minus 3, like that. So it's equal to 0.75 times 10 to the power of what? 7. I'll then put it into what? Into standard form, so that's equal to 7.5 times 10 to the power 7 times 10 to the power negative 1. So it's equal to 7.5 times 10 to the power 7 minus 1. Then my final answer is equal to 7.5 times 10 to the power of what? 6. That is my final answer. So it's done. So let's try to attempt some question papers that I have here with me. Otherwise, that's the end of the standard form. Let's try to attempt some question papers. So we're continuing, guys. I've got a lot of question papers here. I've got a lot of question papers that we're going to do in the standard form. Now we're doing June 2019. There is our question paper. It's June 2019 from ZIMSEC. There are the questions. Express in standard form. There is our first number, our second number. As I said, we're supposed to first determine, is it a normal number or it's an abnormal number? Whenever, if it's a normal number, our index is positive. Whenever it's an abnormal number, our index is negative. And then as I said, we ignore the last zeros if we are giving our answer. In this case, there is the first question. That one is a normal number. We assume the comma is here. So it's going to move 1, 2, 3, 4, 5 times. So that's 6.38. We are going to ignore those zeros just because they are going to be indicated by what? By our index there, times 10 to the power 5. That is our first answer. The second one, that one is an abnormal number just because it begins with what? With the zeros. So we automatically know that our index is negative. So we are going to say it's going to move 1, 2, 3, 4. That's now 4.23 times 10 to the power negative 4. We're done there. Then we're moving on to this one. Whenever, if the indexes are the same, we are going to compute our what? Our working there is 8.76 minus 7.89. Then I'm going to say times 10 to the power negative 2. Okay, just listen here. Here, just because we've got similar or equal indexes, we just take one index. Just because they are the same, we just take one index. Then if it's addition or subtraction here, we simply add or subtract our numbers there. So in this case, it's a 8.76 plus, so it's plus there, 8.76, so it's 8.76 plus 7.89, so that's equal to, so it's equal to 16.65 times 10 to the power negative 2. Now, since we said standard form range is between 1 and 9.9, so our standard position is this one. This number is normal, so we're going to say it's equal to 1.665 times 10 to the power negative 2 times 10 to the power, our comma moved our main times one time. So it's equal to 1.665 times 10 to the power negative 2 plus 1. Our final answer is going to be 1.665 times 10 to the power negative 1. That is the final answer. We are done with that question that appeared in what? In June 2019. Let's move on to the other question. Let's move on to the other question here. Okay, now we've got this question is from November 2012. It's a replacement paper. November 2012, it's a replacement paper. There's the question. If m equals 2.6 times 10 to the power negative 3 and n equals 4.0 times 10 to the power 7, calculate mn giving your answer in standard form. Now, what we have to do here is to simply collect what we are going to multiply. So it's mn is equal to 2.6 times 4.0 times 10 to the power negative 3 times 10 to the power 7. I'm going to say equals, so 2.6 times 4.0, that's equal to 10.4. 10.4 times 10 to the power, I'm going to apply my laws of integers here, negative 3 plus 7, so that's equal to 10.4 times 10 to the power 4. I'll then convert this number into what? Into standard form. That's equal to 10.4 times 10 to the power 4 times 10 to the power, my comma is supposed to move how many times? 1, so power 1 there, so it's equal to 10 point, actually it's no longer 10 point, it's now, okay, let me say 10.4 times 10 to the power 4 plus 1 there, so that I won't omit stages, so that you will try to follow. Now I'm moving on to what? I'm moving on to my final answer. As I move on to my final answer, let me try to use a different ink here so that you will see. So it's equal to, my final answer is equal to 1.04 times my 10 here to the power 5 times 10 to the power 5. I wanted you to see there. So our final answer, that's 1.04 times 10 to the power of what? Of 5. That is the final answer. That is the final answer. Let's move on to the other paper that I have here. So we're now doing our November 2016, that's a paper 1. There's the question. Express 2.54 times 10 to the power negative 1 in ordinal form. We're just going to answer that one question just because B and C, we did it by the time we were doing decimal. So I'm going to answer that one, which says ordinal form. There is our question. I copied it down there. As I said, This index determines that was the number normal or abnormal. As I said, an abnormal number begins with 0 and it has a negative index. In this case, this one was an abnormal number. It contained how many zeros? 1, just because they have got a 1 as our index. So our number was 0.254. That is the answer. Let's move on to the other question. So now we're moving on to November 2018. That's our paper 1. There is the question. It's number 5A, which says express 6.07 times 10 to the power 4 in ordinary form. Now there is the question. As I said, if the power is positive, it means our number was what? Was normal. A normal number is what? Is positive indexes. In this case, we want to convert this number into what? Into its ordinary form. So this form means that our comma is supposed to move 4 times. So this is what? This is the same as 6.07 times what? Times 10,000. So we're going to obtain 607 and 2 zeros. That is our answer. Then the second question was saying evaluate 2.53 times 10 to the power 1 plus 6.1 times 10 to the power negative 1. We have to first convert every number into what? Into its ordinary form. For instance, this one is going to be equal to 25.3 plus this one is what? Is abnormal, so it's going to be plus 0.61. We then arrange our numbers in what? In order. As we add there, we're going to obtain that's 25.3 plus 0.61. That's equal to 25.91. Then I'll convert this number into what? Into standard form. Is what? Is it normal or is abnormal? In this case, this number is normal, so it's equal to 2.519 times 10 to the power of 1. That is my final answer. Let's move on to the other question paper. So our other question is coming from November 2007. That's our paper 2. November 2007. That's our paper 2. There is the question is number 1B. Evaluate. There is the question. It's our number 1B. Let's try to simplify that one. In this case, we are adding, so we have to convert everything into what? Into its ordinary form. So that's 4 times 10 to the power 2. That's equals to 400 plus that one is 6,000 plus that one is 100,000. So I'm going to obtain, it's a 106,040. So actually in this case it's not even necessary for you to use a calculator, just because these numbers end with what? With our zeros. So I'm supposed to convert this number back into what? Into standard form. So we assume the comma is here, so it's going to move 1, 2, 3, 4, 5. So that's 1.064 times 10 to the power 5. We ignore those zeros, they are included in what? In that index. They are included in that index. So that is our final answer. Let's move on to what? To the other question paper. Okay, so we're doing our subtraction. That's November 2017. That's our November 2017. There is the question. It's number 5B, item 2. Simplify. So we're still subtracting. We have to first do what? Convert everything into ordinary form. I think we're now familiar with the what? With the concept. So that's equal to, that one is what? 300 minus, that one is an abnormal number. How many zeros before 2? That's 1. So that's 0.2. So that's equal to, if I say 300 minus 0.2, that's 299.8. Then I convert that one into what? Into standard form. It's a normal number, so my index is going to be what? Positive. So that's 1, 2. So that's 2.998 times 10 to the power of 2. That is my final answer. Let me move to what? To the other question. The other question that I have here is what? It's November 2011. November 2011. Now I want us to interpret this question, the demands of the question. It's our number 1B. The question says, the virus that causes the common cold is 5 times 10 to the power negative 7 meters long. Giving the answer in standard form, find the total length of 12,000 such viruses. This means that is the accumulation of these viruses. We now want to know how many, we now want to know the total length of 12,000 such viruses. If we are given that a single virus is what? Is 5 times 10 to the power negative 7. So in this case, we have to multiply this one and that one. But before we multiply, we have to know that this 12,000 is supposed to be converted into what? Into standard form before we do our multiplication. So let's try to deal with this question. Let's try to deal with this question. It's our number 1B. So that's 5 times 10 to the power negative 7. So it's going to be multiplied by, so if I'm converting 12,000 into what? Into standard form, I assume the comma is what? Is there. So it's going to move 1, 2, 3, 4 times. This one was what? Was a normal number. So it's going to be 1.2 times 10 to the power of what? 4. I just come here and say 5 times 1.2 times 10 to the power negative 7 times 10 to the power 4, it's equal to 5 times 1.2, that's 6. I'm going to obtain my 6 times 10 to the power of negative 7 plus 4, that's equal to 6 times 10 to the power negative 3. That is my what? That is my answer. That is my answer. So let me move on to what? To the other question paper that I have here. As I said, we have a lot of question papers. So I want you to appreciate the concept of what? Of standard form, so that you'll be familiar with what? With how standard form is structured like. So here is our question. Other question that I have is November 2014. That's a replacement paper. There's the question. Given that x equals 2.25 times 10 to the power 6 and y equals 4 times 10 to the power negative 2, and find the numerical value of root sign of x over y. Let's try to solve that question and see. So as I work this question, I'm given the value of x and the value of y. Then I'm required to do what? To find or to determine the root sign of x divided by y. So I'm going to put my what? My values here. So that's 2.25, actually is 2 here, 25 times 10 to the power 6, then below it's 4 times 10 to the power negative 20. I think we did a question that is similar to this one previous. So it's equal to, we first determine the square root. So in this case it's what? It's 1.5 times 10 to the power, then I said we divide this what? This index by 2, so it's 3 there. It's now all over square root of 4, that's 2 times 10 to the power, we divide by 2, so it's a negative 10. Then as I continue, it's going to be equal to 1.5 over 2 times a single 10 there. Which one is this one? I'm going to begin with what? With my 3. Then according to laws of instances, if we are dividing, we do what? We suppress. So it's minus bracket minus 10. I'm going to have equals 0.75 times 10 to the power 3 minus 3, that's what? That's a 13 there. Then moving on to my final answer, I can put my final answer here. Since you are following, you can see what's going on. So from that one, I'm now coming this side. I'll then say this number is what? Is abnormal. So how many times is my comma supposed to move for it to be normal? It's 1. So it's going to be 7.5 times 10 to the power 13 times 10 to the power negative 1. So that's now equal to 7.5 times 10 to the power 13 minus 1. Then I'm moving on to what? To my final answer. That's equal to 7.5 times 10 to the power 12. That is my final answer. That is my final answer. Let me move on to the other question paper that I have here. So as we continue, there is the question is number 20a. Express 3 times 10 to the power negative 4 as a common fraction of 5 times 10 to the power negative 2 in its simplest form. Now we have to understand what this question asks us to do. We are supposed to convert these numbers first into what? Into their ordinary forms. So that's equal to that one. Since it's what? It's a 3 times 10 to the power negative 4. It means that one is an abnormal number. Why do I say so? The power or the index is what? Is negative. Then that index is what? Is 4. It means this comma is supposed to move 4 times. So automatically it's telling me that I have 4 zeros before this 3. So it's 0.123. Then I'll put that 3. Then I'll come and convert that one is to the power negative 2. It means that I have 2 zeros before 5. So that's equal to 0.1 then 5. You see? Now I want to answer the question. The question is saying express this one as a fraction of that one. So it means that it's this number divided by that one. So I'm going to say it's equal to 0.123 over 0.15. Now if I'm converting this number into what? Into a fraction, I'm supposed to eliminate what? My comma. In this case, my comma, as I eliminate it, I'm going to be guided by that numerator. So it's going to be times 10,000 all over 10,000. So I'm moving on to what? To my final answer. On top I'm going to have 3 over, below is what? 500. This is what? My final answer. That's what the question was asking us to do. So in most cases you are supposed to know that whatever you write, you are answering the question. Now we're answering November 2002. There is the question on November 2002. There is the question. We're given M and N. Then our questions, we've got item 1 and item 2. Item 1 demands us to do what? To do our multiplication. So as we do our multiplication, we're going to collect what's possible to be multiplied. So in this case is 3 times 5, then times a singly 10 plus negative 4. There is now equals to 15 times 10 to the power negative 2. Then I want to convert this one into what? Into standard form. That's 15 times 10 to the power negative 2 times 10 to the power is going to move 1 time, so to the power 1. So it's equal to 1.5 times 10 to the power negative 1 there, just because I'm going to do what? To add my powers. Since I think we have done a lot of questions, guys. Let us try to attempt that one, which says we have to do what? We have to divide there. M divided by N. We have to divide M over N. So as we continue here, we're going to say it's equal to, I'll restructure the question and say equals 3 over 5 times 10. The top 10 is the one that comes first and its index, so it's 2. You then apply what? Your laws of indices. You're going to do what? You subtract there, it's equal to 0.6 times 10 to the power of what? Of 6 there. That's now, we want to convert it into what? Into standard form. That's now 6 times 10 to the power of 6 times 10 to the power of what? Negative 1, just because it was abnormal. So it's equal to 6 times 10 to the power of 6 minus 1. It's equal to 6 times 10 to the power of 5. That is our final answer. That is our final answer. So all in all, guys, there's a lot of question papers that I still have here, but I think I'm going to give you those question papers just for the sake of practice. There are still a lot of question papers that I have here. Otherwise, this is the end of the standard form. So let me give you some questions that you are going to practice on. So we've got November 2014, that's a replacement paper. A question on standard form that you're supposed to do for revision. There is the question that you can use for what? For revision, so that you can familiarize yourself and know what exactly is asked in what? In exams. So especially for those who sit for ZIMSEC exam, I think you are going to benefit a lot. I think you are going to benefit a lot from what? From these questions. So take note of that question and do practice. Then this one is June 2012. This is June 24, 2012. Simplify the following, giving your answer in standard form. Simplify the following, give your answer in standard form. I think for that B, you can see what you are supposed to do first before you proceed. You can see what you are supposed to do first before you proceed, since you first apply what? Your laws of indices and determine a fraction that will make you determine what? A decimal. Then the other one, it's June 2015. That's June 2015. There is the question. There is the question number 1C. There is the question. It's number 1C. Given that P equals, that is the question that you have to do what? That you have to practice on. So that is the question you have to do for the sake of practice. Now move on to November 2015. That's what? That's our paper 1 there. That's our paper 1. There is the what? There is the question. It's in the form of a story sum. It's in the form of a story sum. Then on question B is not part of standard form. Question B is not part of standard form. It's just what? It's just a general knowledge question. That one is just a general knowledge. So our standard form is what? It's part A, where you are supposed to subtract and then convert your answer into what? Into standard form. Then I've got November 2001. November 2001 here. This one is just a general question. Express that number in standard form. Express that number in standard form. So I think this is the end of the lesson, guys. We're going to meet on our next lesson, where we'll be doing logarithms. So that is the last lesson that we will do that applies the laws of indices. That is the last lesson which we will do that applies the laws of indices. So this marks the end of our lesson. Thank you for your time, guys.